Good day everyone, my name is Joshua Jatak and today we are going to discuss about the exponent rule. Our first example will be x times x to the power of 3 x to the power of 4 equals x1 plus x to the power of 3 plus x, I mean x x1 plus to the power of 3 plus to the power of 4 equals x to the power of 8. We will multiply the monomials that have the same base, but the thing here is every monomial in the example has the same base. So in other words, we can combine every monomials given in the expression and it will turn into x1 plus to the power of 3 plus to the power of 4. But you may be wondering that why is there an exponent of 1 on the first monomial when there was no given exponent on the first place? This is when the first rule of exponent rules comes in. Our first rule states that anything to the 0 power equals 1. What this means that any variable or base that has no exponent has an imaginary exponent of 1. Hence that the added exponent on the monomials. Adding all of the exponent will result into power of 8. Our monomial value of x the power of 8. Proceeding to the next example is x 2x to the power 2x squared y negative 3x to the power of 3 y to the power of 4 equals 2 times negative 3 times x squared times x to the power of 3 times y to the power of 4. First, we will sort out the values, turning our values into this, then combine every exponent that have the same base and also multiply the coefficients, and the results will be negative 6x to the power of 5 y to the power of 5. Next on the product rule is power rule. Power rule states that when raising monomials to the powers, multiply the exponent. So instead of adding the exponent like we did on the product rule, we will multiply them with the same variable or base. Here in the given formula, our first example is x to the x squared y to the power of 3 to the power of 4 equals x squared times to the power of 4 y to the power of 3 times to the power of 4 equals x to the power of 8 and y to the power of 12. First, we sort out the values and then multiply the exponent by 4 as shown in the expression. The results will be 8 to the power of, x to the power of 8 and y to the power of 12. Next example, 2x to the power of 3 yz square to the power of 3 equals 2 to the power of 3 x to the power of 3 times to the power of 3 y to the power of 3 z squared times to the power of 3 equals 8x to the power of 9, y to the power of 3, and z to the power of 6. First, we sort out the values and then multiply the coefficient by the power of 3 making it 8. Then lastly multiply the exponents. The result will x, 8x to the power of 9, y to the power of 3, and z to the power of 6. Now the last exponent rule on the list is the Now the last exponent rule on the list is the quotient rule. Quotient rule states that when dividing monomials that have the same base, subtract the exponent. So instead of multiplying or adding the exponent, we instead subtract them. Here in the shown formula for quotient rule, so our first example is x to the power of 3 over x negative square equals x to the power of 3 and minus negative square equals x to the power of 5. We first combine the monomials, making our equation x to the power of 3 minus negative square. Since subtracting negative values becomes positive, the negative square exponent will turn into positive square exponent, making the result x to the power of 5. Next example here is 5 to the power of 6 over 5 square equals 5 to the power of 6 negative square equals 5 to the power of 4. We combine and subtract our monomial exponent, making the value 5 to the power of 4. Last in our list is the example 36 m to the power of 3 and to the power of 5 over negative 9 m and n to the power of 4 equals 36 over negative 9 times m to the power of 3 over negative 9 times m to the power of 3 over m times n to the power of 5 over n to the power of 4 equals negative 4m squared n. First, we sort out the values, turning it into 36 and negative 9 multiplied by m to the power of 3 and m multiplied by n to the power of 5 and n to the power of 4. We divide our 36 and negative 9 first, making we divide our 36 and negative 9 first, making the value into negative 4. Then we subtract our variable exponent, making the total value of negative negative 4m squared n. And these are the examples of quotient rule and exponent rules.